Good morning all. Myself Kalai working as Assistant Professor, Selection Grade 1 in Department of Computer Science and Engineering at Erode Sengundar Engineering College. In today's video, we are going to discuss about the topic Gate Level Minimization in Unit 2. So in previous video, we have discussed the simplification of Boolean functions using the Boolean laws and Boolean theorem. In this video, we are going to discuss the simplification of Boolean functions using Karnaugh map. Karnaugh map is simply called as K-map. Actually, a simplification of Boolean function is done by two methods. One is the Karnaugh map and another one is the tablation method. So here we are going to discuss about the Karnaugh map. So map is made up of squares with each square representing one minterm of the function. So Karnaugh map consists of number of cells depending upon the number of input variables. So that cell is nothing but the square. So each square is represented by one minterm. So this produces a circuit diagram with the minimum number of gates and the minimum number of inputs to the gate. So normally the main objective of this K-map is to simplify the Boolean function. The simplification of Boolean function leads to minimizing the number of input to the gates and the number of input to the circuit and the number of gates of the circuit. And it is sometimes possible to find two or more expressions that satisfy the minimization criteria. So sometimes we can able to get two or more Boolean function for a same problem that is almost that is 100% correct. It is depending upon the mapping and minimization criteria, we are getting such type of answers. So that type of two or more expressions are absolutely correct. And what are the types of K-map? 2 variable K-map, 3 variable K-map, 4 variable K-map and 5 variable K-map. So first is 2 variable K-map. The 2 variable K-map has 4 minterms and consists of 4 squares. So how we are getting this is, so by the formula 2 power n. By the formula 2 power n. N is the number of variables. So here number of variables are 2. So 2 power 2. What is 2 power 2? 2 power 2 is 4. So this 2 variable K-map consists of 4 cells. Okay, 4 cells consist of this 4 cells consist of 4 minterms. So the first cell is represented as M0 and second is M1, third one is M2, M3. So this is the way we have to represent the 2 variable K-map. This is the format of 2 variable K-map. So what is M0? M0 is x dash y dash. So here the 2 variables are considered as x and y. So x is represented as row variable and y is represented as column variable. So here is x dash. This is considered as x dash and this is considered as x. Okay, and here this is considered as y dash and this is y. Y dash is nothing but 0. Y is nothing but 1. Similarly, x dash is 0, x is 1. Right? And what is M0? M0 is the combination of the two variables x dash and y dash. And what is this M1? It is x dash y. And M2 is x y dash and M3 is xy. Okay. So if we are having a Boolean function for this, the question may be like this. Simplify f is equal to summation of 3. So this will be given. Okay. So for this we have to plot 1 for the minterm 3 in the K-map. So 3 is M3. M3 is occupied here. So this 1 is marked here. That is 1 is mapped plotted here. And for mapping we have to go with the possibilities of mapping. So first we have to check with the possibilities of mapping for quad possibility, right? So here if you are having all cells occupied with or all cells plotted with 1 means, then that it says that the possibility of quad. Okay, 4 adjacent cells is said to be quad. So here the maximum number of cell is 4 only. So we have to check with the possibility of quad first. Okay, so if you are having a quad possibility, then we can say the answer is, the Boolean function is f is equal to 1. We are having a quad possibility, we can say it is, the answer is, our answer is 1, right? Then if we don't have the quad possibility, then we have to go with the pair possibility. Pair is two adjacent cells. Two adjacent cells is, you can say, the first row or second row. First row, this is a pair, this is a pair possibility, right? So here we can map like this. And second row, that is one pair possibility. And first column, this is another pair possibility. And second column, this is another pair possibility. So if we are having a pair possibility, then we can write the answer as, see here, for example, I am saying here, so if we are considering this pair, so what will be the Boolean function is, on simplification, we will be getting, so this is considered as it is. Here we will be having x dash, okay, and we have to fold this. We have to fold this square to put on this square, so that this y will be sit on this y dash. Y will be sit on this y dash, so that we can say y dash plus y will come. Okay, y dash plus y. So this is said to be 1. This is said to be 1. And what is the row variable we are having? It is x dash. So we will be having x dash. Okay, for this pair, the answer is, or the Boolean function is, x dash only. Okay, so in the same way, if we are having second row as pair, then what will be the Boolean function? Simplified Boolean function we are going to get. So the same procedure we have to follow. So this for this pair, so this cell is going to be sit on this, that is we have to fold like this, so that here y dash, here is y, so y dash plus y becomes 1, and here we are having the variable, row variable as x, so we will getting the Boolean function as x only, right? And if we are having a column pair, suppose if we are having a column pair, so this first column we are having a pair here means, so here also we have to fold this x to sit on this x dash, so that x dash plus x becomes 1, and here we are having y dash, so our Boolean function will be y dash. Okay, and for the second column, so for second column, if you are having a possibility of pair means, here also we have to fold this x to sit on this x dash. So this becomes x plus x dash is 1, and here we are having y. So the answer is, Boolean function is y. Okay, so this is for pair possibility. Then if we don't have pair possibility, then we have to go for single ones. So here actually this problem is having only, this example is consist of only a single minterm. Here we are having this, right? So this is a single one. So what is the minterm for this single one? So we have to combine this row and column. So here is x, here is y. So we will be getting xy. Okay. So for mapping, so first we have to go with the priority. First priority is given to quad possibility. So if we don't have the quad possibility, then we have to go with the pair possibility. And if we don't have the pair possibility, after that only we have to go with the single ones. Okay. And see, this is, so for this Boolean function, simplify f is equal to summation of 3, we are having the Boolean function as f is equal to xy. Okay. And for this example, the question will be like this. Simplify the Boolean function f is equal to summation of 1, 2, 3. 1, 2, 3. Okay. So this will be the question for this K-map, 2 variable K-map. See, M1, M2, M3. Actually, this is simplified by some Boolean laws and theorems. So here we are going to simplify using the K-map. So we have to plot the min terms given in the question. Actually the question is f is equal to summation of. So we have to mention the summation here. Summation of 1, 2, 3. So we have to plot the min terms. So 0, 1, 2, 3. Okay, see here m0, m1, m2, m3. So simply we can remember this as 0, 1, 2, 3. So what is the min term given? 1, 2, 3. So 1 is plotted here, 2 is plotted here and 3 is plotted here. Right? Then for mapping we have to go with the priority. First priority given to quad. So do we have any quad possibility here? No, because so this cell is empty. We don't have any one plotted here. So this is an empty cell. So there is no quad possibility. So if we don't have quad possibility, then we have to go with the pair possibility. Okay, how many pairs are there? So this one can be paired with this one. Okay, and here we are having 1 and this one have to be paired with this one. Okay, so we are having 2 pairs here. We are having 2 pairs. So for this pair, for the column pair, what will be the term we are going to get? So this cell is going to be folded to sit on this cell, so that here x dash and x. So x dash plus x becomes 1 and here is y. So we are getting y here, right? And another pair is here. So this is row pair. For this pair, the same procedure we have to follow. That is, this cell have to be folded to sit on this cell, so that this y dash plus y becomes 1 and x will be here. Okay, so this is x. Okay, so for this pair, for the row pair, the term is x, and for the column pair, the term is y. So this is the function, Boolean function, simplified Boolean function we have got. Okay, so actually this is simplified with the help of Boolean laws and theorem. There also we are having the Boolean function as simplified Boolean function as x plus y, and here it is simplified using the K map. We are getting the same answer, x plus y. Okay, and next is 3 variable K map. So 3 variable K map. How many cells this 3 variable K map consists of? See, we have to follow the same formula. Here we have mentioned the formula, right? 2 power n. So number of cells in the K map can be found with the help of the formula 2 power n. So apply the same formula here, 2 power n. So n is number of variables for this is 3. Okay, so n can be represented as 3. So 2 power 3. So what is 2 power 3? 2 power 3 is 8. Okay, so we can say the 3 variable K map is consist of 8 cells. Okay, and it consists of 8 min terms, right? So here how the terms are represented, see here. So this cell is m0, m1, m2, m3. Okay, and this is m4, m5 and m6, m7. Okay, so it is not arranged in binary sequence. It is similar to gray code. So it is not arranged in binary sequence. So actually m0, m1, m2, m3 have to be followed. m4, m5, m6, m7 have to be followed. Okay, so it is not followed like that. It is followed with the gray code sequence. So m0, m1, m2, m3, m4, m5, m6, m7. Okay, so this is the representation of 3 variable K map. Okay, so what is the m0? So here the variables can be represented as 3 variables we are having. Okay, so here x, that is the row variables are represented x and the column variables are represented with yz. Okay, so this is x dash and this is x. And here yz can be represented as first, for first column it is y dash z dash and y dash z, then yz and yz dash. Okay, so it is represented as binary values. Y dash z dash is 0 0, y dash z is 0 1, y z is 1 1, y z dash is 1 0. Okay, and what is m naught? Combining the variables here. So here is x dash, here is y dash z dash, x dash y dash z dash. Okay, similarly m1 is x dash y dash z, m3 is x dash y z. So m3 is x dash y z, it is nothing but 0 1 1. Okay, you can represent either with variables or with binary values. And what is m2? m2 is x dash y z dash, that is 0 1 0. Okay, and m4 is x y dash z dash, m5 is x y dash z, m7 is x y z, m6 is x y z dash. Okay, and for 3 variable k map, what is the possibilities of mapping we have to follow? So in 2 variable, we have said that first we have to check with the quad possibility. Then quad is nothing but 4 adjacent squares. Okay, so if we don't have the quad possibility, then we have to go with the checking of pair possibility. After that only single ones. Okay, this is for 2 variable. Then what is the possibility of mapping for 3 variable? So we are having 8 cells. So 8 cells here. So 8 adjacent cells. 8 adjacent cells is called as octet. Octet. Octet is 8 adjacent cells. If we are having the plotting of 8 adjacent cells, then there will be a possibility of octet mapping, so that the answer will be 1. So for our octet, if we are having an octet possibility, then we can say that Boolean function is f is equal to 1. Okay, so that is octet is nothing but 8 adjacent cells. Okay, if we don't have octet possibility, then we have to go and check with the quad possibility. Quad possibility is 4 adjacent cells. Okay, so 4 adjacent cells. So what are the 4 adjacent cells here? The first row can be said to be a 4 adjacent cell. The second row can said to be a 4 adjacent cell. Okay, and the first column, second column, it is said to be the 4 adjacent cell. Then the third column, fourth column, it is said to be the 4 adjacent cell. Or the middle column, second column and third column is said to be the 4 adjacent cell. And also the first column and last column, this is said to be the 4 adjacent cell. Okay, and if we are having a quad possibility here, then what will be the term we are going to get? So if we are having a quad possibility here, consider we are having the first row as a quad. Okay, and the answer and the Boolean function and the product term we are going to obtain is x dash. So what is the variable here? This is x dash. So how it is occurred is, so we have to fold all the 4 cells to make it as a single cell, so that all the, so this cells is up to here, we have to make this and to sit on these 2 cells, and again those 2 cells have to be folded to sit on the single cell. Okay, while folding here we are having the different terms. What are the different terms? Z dash, Z, Y dash, Y. So that is considered as 1. Y dash plus Y is considered as 1. Z dash plus Z is considered as 1. Okay. So in here the column variables are considered as 1 here, and we are having the we are going to obtain the Boolean function as x dash only for the first row quad, and for second row quad it is x. Okay, the same way we have to fold and, to make it as a single cell, all the variables on the column will be 1, and we are having the row variable which is x only. So the answer is the Boolean function is x. And if we are having the first two column as a quad, then what will be the Boolean function we are going to obtain for this, or what is the term, standard product term we are going to obtain this? So we have to fold. So these 2 cells have to be folded to sit on these 2 cells. So that, and again we have to fold the second row to sit on the first row. Okay, so in folding that way, this x plus x dash, in folding the row, this becomes x plus x dash, x plus x dash becomes 1, and when folding the column, here you are having z dash, here is z. So z dash plus z becomes 1, and the remaining variable is y dash. Okay, so the term we are going to obtain is y dash only. And if we are having this two column, that is a third column and fourth column, the same procedure we have to follow, that is folding the last column to sit on the third column, and again we are folding the second row to sit on the first row. We will be having x plus x dash, right, x plus x dash, that becomes 1, and here the different variables z plus z dash becomes 1, and we are having y only, right. In the same way for the second column and third column, second column and third column, x plus x dash becomes 1 and y dash plus y becomes 1. We are going to get z as our product term, right. And what will be the term we are going to obtain for the quad possibility of first column and last column? For first column and last column, see the different terms, the different variables y dash, y dash plus y becomes 1. We are having z dash here, and when folding the row, second row to sit on the first row, this x plus x dash becomes 1. So the remaining variable is z dash, right. The Boolean function we are going to obtain is z dash alone. So this is quad possibility. Then quad is 4 adjacent cells. After that we have to check with the pair possibility. If we don't have quad possibility, then we have to check with the pair possibility. What are the pairs? 2 adjacent cells are the pairs. So here m0 and m1 are pair, m1 and m3 are pair, m3 and m2 are pair, m0 and m2 are pair, m0 m4 are pair, m1 m5 are pair, m3 m7 are pair, m2 m6 are pair. Okay, so many pairs are available here. And m4 m5 m4 m5 m5 m7 m7 m6 m4 m6, all those things are pair. And we can't say m5 and m6 are pair. Okay, so this is here, this is here, so this is not adjacent, so this is not a pair. Okay, then what is the term we are going to obtain for a pair possibility? See here, suppose we are having a pair here, so we are having a pair here, then what will be the product term we are going to obtain? So for this pair we have to fold the second row to sit on the first row, so that this x plus x dash becomes 1, and here we are having the column variable as y dash z dash. So the term we are going to obtain is y dash z dash. Okay, if we are having a pair here, we are having a pair here, so this have to be folded, m3 fold in such a way that m3 have to be sit on m1, or you can say m1 have to be sit on m3. For this, here the two column consist of the different variables y dash and y, so y dash plus y becomes 1 and remaining is z. So in this column variable we are having z variable, column we are having z variable, in the row we are having x dash. So x dash z is the term to be obtained for this pair, right. And for corners, so for example m4 and m6, for m4 and m6 what will be the term we are going to obtain? So here consider first column and last column, fold the last column to sit on the first column, so that y dash plus y becomes 1, the remaining is z dash. So here the variable, row variable is x, so x z dash is the term which is obtained for this column pair. Okay, So this is pair possibility. Pair possibility in 3 variable K-map. Then next comes single ones. If we don't have any pair possibility, then we have to check with the possibility of single ones. Okay, single ones, no problem. The corresponding minterm of the square have to be written. So if you are having a single one here, so this have to be written as, here is x dash, here is y z dash. The minterm of m2, minterm m2 have to be written as it is. Okay, x dash, y z dash. And for the remaining single ones also, we have to write the corresponding minterm. Okay, so this is the way we have to make the 3 variable mapping. Okay, so here if we are having a problem given, so what is the problem is, simplify f is equal to summation of 5 and 7. F is equal to, simplify f is equal to summation of 5 comma 7 using 3 variable K-map. So this is the question. This is the format. In this way the question will be given. See here, 5 and 7, minterm 5 and 7 is, so this is 5, this is 7. So we can remember like this. This is 0, 1, 2, 3, 4, 5. So 5, minterm 5 is given in the question. So for the square M5, we can mark 1 here. Plot a 1 here, and 6, 7. So this is 7. Okay. So here a 1 have to be plotted. So these two are adjacent. Okay. So before writing the answer, we have to check with the possibilities of mapping. First we have to check with the octet possibility. We don't have any octet possibility. 8 adjacent squares are not possible here, and we have to go with a quad possibility. Quad possibility is 4 adjacent square. 4 adjacent square is also not possible here. Then next we have to check with pair possibility. So this is pair. Okay, for this pair, what is the answer we are going to get? So this cell have to be folded to sit on this cell, so that here the difference is y dash y becomes 1, y dash plus y becomes 1. Here we are having the variable z, and here we are having x. So xz is the answer. Xz is the Boolean function for this question. See here. So this is simplified with the help of Boolean laws and theorems. Answer is xz. So here, so this is simplified using Karnaugh map. 3 variable Karnaugh map is applied here, so that we are getting the Boolean function as xy. So this is the way we have to solve the 3 variable K map. So next, simplification of the number of adjacent squares. So a larger number of adjacent squares are combined, we obtained a product term with fewer literals. Okay, so this is for 3 variable K map. They are saying we are having a single one possibility, that is we are having we don't have octet, quad possibility, pair possibility. We are having only one cells or there, means that is it is said to be one square. So if we are having one square, then it is the minterm. What is the minterm of that square we have to write. So that minterm consists of how many literals? It consists of 3 literals. Okay, for single one, the number of literals for that product term will be 3 literals, and 2 adjacent squares, that is we have said that it is a pair possibility, right? So for that pair possibility, we are going to obtain that term that consists of 2 literals. It consists of 2 literals. Here we have discussed, right? So here, so this is a pair possibility. So for this pair possibility, what is the term we are obtained? X z. It consists of how many literals? So x is 1 literal, z is another 1 literal. So it consists of 2 literals. Okay. And Then next is 8 adjacent squares, sorry, 4 adjacent squares. For 4 adjacent squares we are going to obtain the one term. 4 adjacent square is nothing but quad possibility. For quad possibility we are going to obtain one term. That one term consists of one literal. See, here we have discussed. So this may be a quad. First row may be a quad or second row may be a quad, and first two column may be a quad, or second column and third column may be a quad. Okay, so for example, if you are having the first row as quad, what we have discussed, all the variables in this column are considered as 1. That is, the different variables y plus y dash is 1, and z plus z dash becomes 1. Okay, all these things are becomes 1, and we are having the boolean function as x dash alone. Okay, so x dash is a single literal. X dash is a single literal. So if you are having a quad possibility, then the number of literals in the term is 1. Right? So 1 literal. For quad possibility, for 4 adjacent squares we are having 1 literal. And 8 adjacent squares. 8 adjacent square. What is 8 adjacent square? What we have discussed? 8 adjacent square is octet. So what is the boolean function we are going to obtain for an octet? We have discussed here, no? So for all the 8 adjacent cells is plotted, means we have to combine all the 8 cells and it becomes 1. Here we have written octet means the boolean function is f is equal to 1, right? All the column variables becomes 1, and the x plus x dash, this row variable also becomes 1. Okay, the final boolean function is f is equal to 1 if you are having an octet possibility. Octet possibility is 8 adjacent squares, right? Okay, it is obviously to know the number of adjacent squares is combined in a power of 2, such as 1, 2, 4, 8. That is 2 power 3 is 8, 2 power 2 is 4, 2 power 1 is 2, and 2 power 0 is 1. So it is adjacent. How we are forming the adjacent squares? It is with this power of 2. Next we are having another example here. So simplify f of x, y, z equal to summation of 0, 2, 4, 5, 6. So for this we have to put the k-map, 3 variable k-map first. After that we have to plot the min terms with 1. Plot the min terms, corresponding min term in the k-map have to be plotted with 1. So what is given? 0 to 4, 5, 6. So this is m naught. Here we have to plot 1, 0, 1, 2. Here we have to plot 1. So 0, 1, 2, 3 we don't have, 4, 5, 6 we are having, 7 we don't have. So what are the min terms given in the problem? That have to be plotted as 1 in the k-map. The corresponding squares have to be plotted with 1. After plotting, we have to go with the mapping possibility. So for mapping, we have discussed previously. So we have to go with the preference. First preference is for octet possibility. Do we have any octet possibility here? No. So 8 adjacent cells are not plotted here, right? So we don't have octet possibility. Then quad. So this column, first column and last column. So this makes a quad. Okay. And after that we are having a pair here. So this is a pair, right? So after mapping we have to write the terms for the quad and the pair. What is the term for this quad? What is the term for this quad? For this quad, so this is quad. Okay, here the different terms is, this becomes y dash, this becomes y, right? So y dash plus y becomes 1, and here we are having z dash. So 0 says that z dash, and here also we have to fold this second row to sit on the first row. Here the last column is folded to sit on the first column, and here the second row have to be folded to sit on the first row. Okay, when column folding, this y dash plus y becomes 1, and row folding, x dash plus x becomes 1, and what is the term we are going to obtain is z dash. So here this is z dash, right? And for this pair, here another one pair is here. This pair, what is the term to be obtained? For column, we are having the different variables. This is z dash, this is z. So z dash plus z becomes 1, and this is y dash. So here we are having the column variable as y dash, and the row variable, so row is considered as it is x. Okay, so we are folding the first row, first column to sit on the second column. So we are folding the column only, not the row. So when folding the column, the different variables of the column becomes 1. Okay, so there is no change in the row variable. So we have to consider x as it is. So here x, and in this we are having y dash. So the next term is x y dash. So for this squared, the term obtained is z dash, and for this pair the term obtained is x y dash. Okay, the simplified Boolean function for the given problem is f is equal to z dash plus x y dash. Okay, the next is 4 variable K map. So 4 variable K map consists of how many cells? 2 power n formula. What is n? Number of variables of 4, right? So what is 2 power 4? 2 power 4 is 16. So this 4 variable K map consists of how many cells? 16 cells, right? So how it is represented? This is M0, M1, M2, M3, M4, M5, M6, M7, M8, M9, M10, M11, M12, M13, M14, M15. So this is the K map, format of 4 variable K map. Okay, and while simplifying, we have to go with the possibilities of mapping. What is the possibility? First, we have to check with the 16 adjacent cells. So 16 adjacent cells is all the squares are plotted with 1. Then we can say it is a possibility of 16 adjacent cells. Then if we are having a 16 adjacent cell, then the answer is 1. Okay, so before we will discuss the variables here. So here we can say the variables as wx and yz, right? So this is w dash x dash, and this is w dash x, wx and wx dash. And what about the column variable? It is y dash z dash, y dash z, and this is yz and yz dash. Okay, and what is m0? M0 is combining the row variable and the column variable. What we are getting? W dash x dash, and this is y dash z dash, y dash z dash. M0 is w dash x dash, y dash z dash. In the same way, we can obtain the term for the remaining minterms also. Okay, right. Then while coming to the possibilities of mapping, we have to check with the first possibility of mapping is 16 adjacent cell. We are having a 16 adjacent cell, then we can say the Boolean function for that 16 adjacent cell is 1. Okay, then 8 adjacent cell, 8 adjacent cells or 8 adjacent squares. 8 adjacent squares is nothing but octet. So what is the octet possibility here? You can say 8 adjacent cells or the first 2 column, or the second column and third column, or third column, fourth column, first column, last column. Okay, and also for the row, first row, second row, or second row, third row, third row, fourth row, or first row, fourth row. This is a possibility of 8 adjacent squares. Okay. What will be the term we are going to obtain for the octet? So, for example, consider we are having the first two column as the octet possibility. And what is the answer? What is the term to be obtained is all the row variable becomes 1. All the row variable becomes 1. So, in the column variable, the different variable is z as z. So, z as plus z becomes 1. The only variable remaining is y dash. So, the answer is y dash. Okay. So, for octet possibility, we are having the term as y dash. Okay. So, y dash consists of only one literal. So, here it is mentioned as one literal. Right. So, for octet possibility, we can obtain a one term. That one term consists of how many literal? Only one literal. So, here we have discussed this first two column octet. Okay. Then, next, 4 adjacent squares. 4 adjacent squares as quad possibility. Quad possibility is, we can say the adjacent 4 adjacent cells. So, this is a quad possibility, this is a quad possibility, or this is a quad possibility, and also here this is a quad possibility, this is quad possibility, this is quad possibility, and here also we can say if you are having the term plotted m5, m4, m5, m12, m13. So this is a quad possibility, and also the corner cells m0, m2, m10, m8. If it is plotted, then that is said to be a quad possibility. Okay. For example, we are having a quad possibility here. Can say a quad possibility here. And what is the term we are going to obtain this? So we have to fold in such a way that the second row have to be sit on the third row, or we can say the third row have to be sit on the second row, and also the second column have to be sit on the third column, and that to be folded again to make it as a single cell. Okay, if you are doing like that, so in this the row variable w dash plus w, this becomes 1. The remaining what we are having? X. So this is for row. And what about column? So here y dash plus y becomes 1. The remaining variable we are having is z. So here we are having x, here we are having z. So we can say the term as xz. Right? So how many literals are here? 2 literals. Right? So for 4 adjacent cells, that is if you are having a quad possibility, then the term we are obtained is consist of 2 literals. Okay. Then, so next, after that, if we don't have quad possibility, we have to go and check with the possibility of pair. So what is the pair possibility here? So the 2 adjacent cell is pair, right? So any 2 adjacent cell. So m0, m1 is pair, m1, m3 is pair, m3, m2 is pair, m0, m8 is pair, m0, m2 is pair, m4, m12 is pair. Okay, all these are pair. Okay, so for example, if you are having the minterm cell m2 is plotted with 1 and m10 is plotted with 1, then we can say here is a pair possibility, right? What will be the term we are going to obtain for this pair? See here the row variable, the different variable w dash plus w becomes 1. And what we are having here? X dash. And what is the column variable? We have to consider this column variable as it is. So this is y z dash. Okay. So for the pair, how many variables or how many literals are there? Consist of 3 literals. So it is here. So for a 2 adjacent squares, that is if you are having a pair possibility, then we can obtain a term. That term consists of 3 literals. Okay. Then if we don't have any pair possibility, then we have to go for a single cell. Single cell is 1 square. 1 square, we are going to obtain a term that is said to be the min term. the minterm of the corresponding cell. Here this is one cell. This is one cell, and this one cell is single cell. And what is the minterm for this? W x dash y dash z dash. W x dash y dash z dash. Okay, how many variables are there for this, or the literals? Here 4 literals. Okay, if you are having a single cell, then the number of literals are 4. Number of literals are 4, right? So first, if you are having a 16 adjacent square, then the Boolean function is 1. And we are having a 8 adjacent square, that is an octet possibility. Octet possibility, we will be having only one literal. That is, the term consists of only one literal. And for 4 adjacent squares, we are having one term that consists of 2 literals. For 2 adjacent squares, that is for pair possibility, there are 3 literals. And for a single one, consists of 4 literals. Then, so this is an example for a 4 variable K-map. Actually, what will be the question for this is, f is equal to, simplify, f is equal to summation of, this is 0, 1, okay, 0, 1, 2, 2, 3, 4, 5, 6, 2, 6, 7, 8, 9, 8, 9, 8, 9, 10. This is 10. 10. That's all. This will be the question given. Okay. Actually, this question, this Boolean function is given as sum of product. The sum of product Boolean function have to be converted to sum of min terms. We have discussed in the previous video how to convert a sum of product to sum of min term. That is how to convert a standard form to canonical form, that we have discussed. So we have to check with each and every term. If any of the term is missing with any variable, that missing variable have to be included. So that we have discussed in the previous videos. Okay, so by expanding this or by converting the sum of product into sum of min term, we can obtain this 0, 1, 2, 6, 8, 9, 10. Okay, and how can we simplify this? So we have to plot this min term in the K-map, 4 variable K-map. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 are not given. Okay. So what are the min terms we have obtained by the conversion process have to be plotted in the K-map. After that, we have to go with the mapping. So what are the possibilities of mapping here? So for 16 cells, that is for 4 variable K-map, we have to go with the preference of 16 adjacent cells. So is there any 16 adjacent cells here? No, we don't have 16 adjacent cells. And we have to check with octet possibility, 8 adjacent cells. So we don't have any 8 adjacent cell here. And we have to go with checking of quad possibility. So quad possibility is 4 adjacent cells. So this is one quad here and here. So the yellow marked, this is one quad, and the corner ones, the blue marked, right? So this is another one quad. This is another one quad. Okay, 2 quad possibilities are there. So after that, and one pair is here. Here we are having a 1. So this 1 can be mapped with this one to make this as a pair. Okay, so in this K-map, we are having 2 quad possibility and 1 pair possibility. 2 quad and 1 pair. So what is the term we are going to obtain for the quad? So for this quad, what is the term we are going to obtain? So this is a dash, this is a dash plus a becomes 1 and the remaining is b dash here. Okay, and in this column this is d dash, this is d, this d dash and d becomes 1 and the remaining is c dash. So b dash c dash is the term for this quad. Okay, yellow marked quad. So here we have got this b dash c dash. And what about the corner quad? That is the blue marked one. So for this quad, corner quad, so here a dash a, this becomes 1, a dash plus a becomes 1, remaining is b dash. Okay, and what about the column variable? Column variable c dash, here is c, c dash plus c becomes 1 and the remaining is d dash, b dash, d dash. So this is the term obtained here. Okay, the blue marked quad. And what about the pair here? The violet marked is the pair here. So what is the term for this pair? So this is b dash b. b dash plus b becomes 1 and the remaining is a dash. So here is a dash. And what is the variable for this last column? Here is c d dash, c d dash, a dash c d dash, a dash c d dash is the term. Okay, so this is the way we have to simplify the Boolean function using K-map, right? So actually the original number of terms in the Boolean functions, or the original Boolean function consists of 4 terms. Okay, so these are the 4 terms, and also it involved with more number of literals. Each and every term involved with more number of literals. So this is simplified using K-map so that we can get the 3 terms, and 3 terms the literals also minimized here, the number of variables also minimized here. Okay, so from this we can able to understand the simplification of Boolean function using K-map. So this is 4 variable K-map. So in this 4 variable K-map, or in K-map, we can say an important term, that is essential prime implicant, and another term is prime implicant. So what is essential prime implicant? So if a min term in a square is covered by only one prime implicant, that prime implicant is said to be essential. If a min term in a square is covered by only one prime implicant, that the prime implicant is said to be essential. That the prime implicant is said to be essential. See here. So here we are having a quad possibility. Here also we are having a quad possibility. Right. So in this, the min term, all this min term, this min term, this min term, all the min term is covered by only one prime implicant. Right. So this quad is b d, and the corner quad is b dash d dash. So this is essential prime implicant. If a min term in a square is covered by only one prime implicant, that prime implicant is said to be essential. Then prime implicant. Prime implicant is a product term obtained by combining the maximum possible number of adjacent squares in the map. Prime implicant is a product term that is obtained by combining maximum possible number of adjacent squares in the map. So here is an example. In this, which are all the product term which is combined maximum possibilities of mappings or maximum possibilities means that is said to be a prime implicant. See here the minterms m3, m9, m11. Okay, so in these three minterms m3, m9, m11 is covered by the maximum number of product terms. So which are all the product terms that consist of these three minterms is said to be prime implicant. CD, B dash C, AD, AB dash. So these are the product terms which are all said to be prime implicant. So next is 5 variable K map. So for 5 variable K map, how many cells are there? 2 power 5. 2 power 5 is 32 cells. We are having 32 cells. So this is a 5 variable K map. So this 16 cells. Here the 16 cells. And we are combining this. That is 32 cells. Okay. And this 16 cells are for A equal to 0. And these 16 cells are for A equal to 1. So what are the 5 variables involved here? So this is A equal to 0, that is A dash. All the terms involved here are all the minterms involving in these 16 cells. That A variable is represented as A dash. And in these 16 cells, the A variable is represented as A. Okay. And the remaining 4 variable, the row variable is BC and the column variable is DE. Okay. And the minterms are M0, M1, M2, M3, M4, M5, M6, M7, M8, M9, M10, M11, M12, M13, M14, M15. Here M16, M17, M18, M19, M20, M21, M22, M23, M24, M25, M26, M27, M28, M29, then M30, M31. Okay. And how we are going to map this? So if you are having the 32 adjacent cells, 32 adjacent cells are plotted, then the possibility of mapping is 32 adjacent cells, then we can say the answer is F is equal to 1. F is equal to 1. After that, we have to go with the checking of possibility of 16 adjacent squares. 16 adjacent squares are, this is a 16 adjacent square, this is a 16 adjacent square, and the first two row, these two row and these two row. So this makes a 16 adjacent squares, and these second and third and fourth. Okay, this is a 16 adjacent square. And for column also, first column, second column of the first 16 cells, and the first column, second column of first 16 cells. This also forms a 16 adjacent cells. And also we can say the first row and the last row, right? And for after that we have to go with the octet possibility, 8 adjacent cells. 8 adjacent cells is same as what we have discussed in the 4 variable K map. So the first two column in these cells and these cells also, and when we are combining these two, so first column and this first column, this forms a 8 adjacent cell, and also the first row, this first row forms a 8 adjacent cell. Okay. And we can't say this first column and the last column as octet. This is not an octet. The corresponding columns have to be mapped. So first column and the first column, this first column and this first column is possibility of octet, and the first last column of this one and the last column of this one. This is a possibility of octet. We should not say that the first column and the last column of this. The first column of the first 16 cells and the last column of the second 16 cells is not a possibility of octet. Okay. So how it is considered is all the 16 cells have to be take and it have to be kept upon this. Okay, we should not fold. So we should not fold this these 16 cells to sit on this. We should not fold like this. Folding should not be done. We have to take all these 16 cells and to kept on this one. So that the min term 0 have to be, or the min term 16 have to be sit on min term 0. See, here it is mentioned. Min term 21 have to be sit on min term 5. Okay. So here is the pair possibility. The 5 and 21 is mapped, means it is said to be a pair possibility. Then quad we have discussed. What is the thing we have discussed for 4 variable is applicable here. Okay. This first column and the first 2 rows, and here the first column and the first 2 rows, this forms a quad. Okay. Next pair. So this forms a pair. After that, single ones. Okay, for 5 variable map we have to go with checking of 32 adjacent cells. After that 16 adjacent cells. After that 8 adjacent cells. After that 4 adjacent cells. After that 2 adjacent cells. After that single ones. And this table shows that how many number of literals will be there for the number of variables. If the K map is n variable K map, and that K map consists of how many number of literals. So this we have discussed in the previous slides itself. It is consolidated here. Okay, so we will discuss here. So for n equal to 5, for 5 variable K map, if we are having the adjacent squares, number of adjacent squares as 1, there is a possibility of single one. Single one means the number of literals. So if we are having a single one here, so this is the term we are going to obtain, means the number of literals is, what is the min term for this? It is A, and here is B, C dash, and this is D, E. Okay. So how many literals are here? 5. So that is discussed here. Okay. If you are having a single one, then the number of literals in that term will be 5. Then we are having a pair possibility. Then the number of literals will be 4. We are having a quad possibility in 5 variable K map. Okay, quad possibility in 5 variable K map. Then the number of literals will be 3. Then if you are having an octet possibility, the number of literals is 2. Then 16 adjacent cells. We are having 16 adjacent cells. The number of literals is 1. And we are having 32 adjacent cells. 32 adjacent cells means we don't have any literal. Because we said that the answer is 1. F is equal to 1 have to be written. So it consists of no literals. So it is marked as 0. So this is for 5 variable K map. In the same way, it is given for 4 variable K map, 3 variable K map, and 2 variable K map. Right? So it is possible to show that any 2 power k adjacent squares for k equal to 0, 1, 2 up to n in an n variable map will represent an area that gives a term of n minus k literals, that is n greater than k. When n equal to k, it is identity function. So n equal to k, that is n is number of variable. So 5 variable, if 5 is equal to 5. Here the k is 5, right? N is also 5. So for that, the function is an identity function. We have discussed here. So we are having the function as f is equal to 1. So it is represented here. It is identity function. So next is an example. Example 5 variable k map. So the minterms given is f of a, b, c, d, e equal to summation of 0 to 4, 6, 9, 13, 21, 23, 25, 29 and 31. And so this have to be plotted here. 0, 1, 2, 4, 6, 8, 9, 10, 11 is not there. 12 is not there. 13, 15, 16, 17, 18, 19, 20, 21 is there. 22 is not there. 23, 24, 25 is there. 26, 27, 28, 29 is there. 30 we don't have the minterm. 31 is here. So after plotting these minterms in the K map, we have to map. So what are the possibilities of mapping? So here is a first we have to check with the priority. First we have to check with 16 adjacent cells. We don't have 16 adjacent cells. After that we have to go for 16 adjacent cells. Here also there is no possibility of 16 adjacent cells. After that 8 adjacent cells. We don't have 8 adjacent cells here. And next is 4 adjacent cells. 4 adjacent cells is this is one 4 adjacent cell, orange color marked or red marked. Okay, and here is another one 4 adjacent cell, green marked. So this is one 4 adjacent cell. This is one quad, and this blue marked. This is also one quad. So totally we are having 3 quad here. So in this 5 variable K map, we are having 3 quads. Okay, for this quad, what is the term obtained is, so first we have to consider A dash and the different variable here is C dash plus C. C dash plus C becomes 1 and here we are having B dash. Actually first we have to consider A dash, and that is for these 16 cells we have to consider A dash, and for these 16 cells we have to consider A. Okay, so when we are taking these 16 cells to kept over these 16 cells means that time, at that time this A dash plus A becomes 1. Okay, so so for this quad, so this is A dash and here this C dash plus C becomes 1 and B dash is here. And what about this column? Here is D dash, this is D. D dash plus D becomes 1. Remaining is E dash. So A dash, A dash, B dash, E dash. A dash, B dash, E dash is the term obtained for this quad. Okay. And what about this green quad? For this green quad, A is there. And in this B dash plus B, this B dash plus B becomes 1. So here is C. And in this D dash plus D becomes 1. Remaining is E. So ACE. ACE is the term which is obtained for this green quad. So this is the term here, ACE. And what about this blue quad? So for this blue quad, we have to take these 16 cells to kept on these 16 cells. Okay, at that time this A dash plus A becomes 1. A dash plus A becomes 1. And when folding the last row to sit on the third row, here this C dash, here is C dash. C dash plus C becomes 1. And the remaining is B. So B we are having in this, and this column is D dash E. The same thing is here, D dash E. Right? So for this it is B, for row variable it is B, in the column variable it is D dash E, right? So this is the term we are having, B D dash E. Okay, so this is example of 5 variable K-map. Conclude this video. So we have discussed 2 variable K-map, 3 variable K-map, 4 variable K-map and 5 variable K-map with example problems. Thank you.